Hey everyone, so today I will be telling you about motion graphs. Motion graphs, you can have distance time graphs, velocity time graphs, acceleration time graphs, any of these graphs. I'm going to focus more on the distance and velocity because this video is more towards GCSE, but I do have a playlist on A level about motion graphs, so forces in equilibrium or maybe mechanics, I believe is the mechanics one that tells you about the other graphs as well, okay? So, as you can see, I have more than three. I have five exact same lines, but they mean different things according if you have a distance time graph, which is the first graph we have in here, or a velocity time graph, which is the second graph. So, a horizontal line on a distance time graph means that no distance changes over time, so the object is stationary or stopped. If the line has a very steep gradient, it means that the object is increasing the distance quite a lot in a short amount of time, so the object is moving quite fast. If the object has a straight line as well, but the gradient is not as steep, it means that it's moving still. However, the distance that it travels is not as high, so it's moving away slowly, okay? If you have an object where the line is going down, it means that the distance is decreasing over time. This is moving back, so moving a distance in an opposite direction. I have to say that this picture was taken from the internet. This would be fine for displacement time graph because distance is a scalar, but anyway. You get the idea. And then if you have a curve, it means that the speed that the object is moving is not a constant speed, it's a changing speed. So it's moving it away and getting faster because the inclination of the line becomes steeper, okay? Now, if I have a velocity time graph going through the exact same lines, a straight horizontal line is going to mean that the velocity does not change over time, so it means constant velocity. A line that is straight but quite steep means that the velocity is increasing over time quite fast. So I have a rapid acceleration. If the line is still a straight line, it means that I still have acceleration, but because it's not as steep as the other line, it means that my velocity does not increase that much over time. So it's an acceleration, a slower acceleration. If the velocity decreases over time, it slows down steadily. And if I again have a curved line, it means that my velocity is a changing velocity. And in this case, because the steepness of the line increases from an acceleration to a steady, rapid acceleration, it means that it is increasing in acceleration, okay? So that means that in motion graphs, I need to look at the axis, okay? Also, in velocity time graphs, I don't have to just say in terms of velocity, I can talk about acceleration. So for example, again, I have constant acceleration, constant velocity, constant deceleration. That's the same as saying for constant acceleration that I have a positive acceleration. When I have constant velocity, it's the same as saying that I have zero acceleration. And when I have a constant deceleration, it means that I have a negative acceleration or deceleration, okay? So all that you need to do when you have a motion graph is look first at the axis to see if it's distance or velocity time graph. And then remember that certain things can have the same name, different names and mean the same thing. So constant velocity is the same as zero acceleration. Decelerating is the same as having a negative acceleration or slowing down. And speeding up is the same as having constant acceleration or positive acceleration. All right? Now, with a velocity time graph, because velocity is a vector, I can also have a negative velocity, okay? So here is an example of a graph, a velocity time graph of an object going up and down. So imagine that I throw a ball in the air and then I take a velocity time graph of the whole motion. This is how it would look like. A straight line with the same gradient going down, okay? So what does that mean? I have a straight line going down, so my velocity decreases over time. So I decelerate as I go up. So my object is going up and decelerating steadily. Then at B, I have zero. Now, zero velocity means that the object stopped moving, okay? So stop moving. So there I have zero acceleration. And now the velocity starts to become increasing in number, but becoming negative. So I am changing direction of motion because, as you know, I have positive velocity if I go in one direction and negative velocity if I go in another direction. So at B, I have zero velocity. My object stopped and decided to change direction. So now it's not going up anymore, it's going down. And then I have the velocity increasing over time. So I accelerate as I move down. So this is an example of a velocity time graph where people can sometimes believe there is deceleration throughout the whole motion, but actually think about numbers. Velocity is getting bigger and bigger in terms of numbers, more and more negative, but that means that it's just accelerating in the opposite direction to the motion, okay? Now, how do I know if I have constant or changing speed in a distance time graph or even in a velocity time graph? I could have put that as well. If I have a straight line, the object is moving at constant speed or constant velocity or constant acceleration. If I have a velocity time graph, and if I have a curved or not a straight line, it means that the motion is changing. I'm either changing speed or changing acceleration, okay? So, for example, in this velocity time graph, I have accelerating motion because my line is a positive straight line going upwards. Then I have steady speed, same as saying constant velocity, same as saying zero acceleration, when the velocity of my object does not change over time. And then I have deceleration, when the object of my velocity of my object decreases over time. And then I have an increasing acceleration. Now my acceleration is not constant anymore because my line now is a curve. And again, how do I know if the acceleration is decreasing or increasing? I just look at the trend on the curve. I imagine straight lines, and this line definitely has a steeper gradient than this line in here. So because the steeper the gradient, the bigger is my change of motion, velocity or acceleration, I know that I have an increasing acceleration. More stuff we need to know about graphs. Well, I can figure out velocity or acceleration by calculating the gradient of my graph. A distance time graph gives me velocity because velocity by definition, by formula, is distance traveled over the time taken. So if I calculate the gradient, I get velocity. On a velocity time graph, if I calculate the gradient, I get acceleration. And this is because acceleration, by definition, is change in velocity over time taken. So again, if I figure out how much I changed in velocity, the y-axis, over the time that it took me, the x-axis, I get acceleration, okay? And this goes both for accelerating motion or decelerating motion, okay? Now, in case you don't know how to calculate the gradient, is calculating the rise that you had over the step that it took for you to have this rise. So for example, in here, I have a rise of 6 squares and it took me 3 steps to get this rise. So my gradient will be the rise over step, 6 over 3, and the gradient will be 2. If this would be distance in meters and time in seconds, this would be 2 meters per second for velocity. If this would have been a rise in meters per second of the velocity in time in seconds, it would give me 2 meters per second squared, and it would be this acceleration, okay? Now, finally, last thing you need to know about graphs. I'm giving you like all the information on graphs in one video only. The distance traveled, if you want to calculate the distance traveled by looking at a graph only, is very simple. You simply need to figure out the area under a velocity time graph, okay? So the area under a velocity time graph gives you the distance that you travel. Because again, think, what is distance? Distance is velocity times time. So when you calculate an area, you do side times side, right? So the area under a velocity time graph, you would do velocity times time, which is distance, and this would be the area under the graph. Okay, so for example, in here, calculate the distance traveled. This is a question from AQA. So I have here this shape, And if I don't know how to calculate the shape, the area of the shape as it looks like, I can divide the shape into areas that I can calculate. So I can make this into a purple triangle and a red rectangle, okay? And all that I need to do is figure out the area of my rectangle, add up to the area of my triangle, and I get the total distance traveled. So the distance traveled is going to be the area under the distance time graph. So it's the area of the triangle plus the area of the rectangle. The area of the triangle is going to be this distance. So that's going to be 10 times the height. So I went from 4 to 12. So that's going to be a distance of 8. So that's going to be the height times the base, so 8 times 10, and then a triangle is the same as a rectangle divided by 2, so I divide by 2, okay? So it's 8 times 10 divided by 2, plus the area of this side, base is 10, the height is 4, so 4 times 10. This would give me 80 meters, okay? Because I have 40 plus 40 meters. And that is it. That's all you need to know about motion graphs, either if they are or whether if they are distance time graphs or velocity velocity time graph. So up to my next video, be happy and healthy. Bye.